And we really believe that by using open standard, the open standard we promote in LIGATE, which are alternative to proprietary non-European solution, this is a great benefit for the European community.
Welcome to Chelonia Podcast, a podcast about the use of scientific discoveries and of technology applications. We provide the best information on projects participated by Chelonia and many more. My name is Gabriella Bernardi. I'm a science journalist, and in today's episode we talk about the LIGATE project with Professor Biagio Cosenza from University of Salerno. It's nice to meet you, and would you please introduce yourself and tell us something about the role of your company in the LIGATE project?
My name is Biagio Cosenza. I'm professor at the Department of Computer Science at the University of Salerno in Italy. Before to join University of Salerno, I've been senior researcher at TU Berlin for 5 years and postdoctoral researcher at the University of Innsbruck in Austria for 4 years. So my research expertise is on high-performance computing, and specifically to this project, with my research team, we are working on programming models and optimization for high-performance computing system. You may think that what we do is, on the one hand, to develop and optimize code that is capable to get the maximum peak performance on modern hardware. And on the other hand, we also work on designing and developing highly programming models so that scientists can easily use those performance improvement on their applications.
So, what are the goals that you expect from the LIGATE project?
The main goal of the LIGATE project is to accelerate the process of drug design. And drug design is a computational intensive process. It takes a long time to test all the different molecules against several pathogens. Our goal is to deliver a software stack which is capable to fully use the computational power of modern supercomputers, and that is able to drastically accelerate the process of drug design. What I expect is that thanks to all the technical advances, we are developing like support for heterogeneous hardware, static runtime optimization, integration of communication optimization to scale on hundreds of nodes, we can make the drug design order of magnitude faster than current state-of-the-art approaches.
What do you think are the benefits for European community and for society in general?
So, as the LIGATE project is about accelerating the process of drug discovery, this clearly has a huge impact on society. But let me stress also another aspect, which I believe is very important for the European community. The two core software technology we are developing in LIGATE are based on open standard. And I'm talking about the SQL programming model, which is a standard by Kronos Group for programming heterogeneous parallel devices. And I'm talking about our extension to SQL, which is called Celerity, and is developed by us in collaboration with the University of Innsbruck. Overall, this will help to build a completely open software ecosystem for supercomputers. And this is good for several reasons. It is good because it allows programmers to write their code in a portable way, and that will run on today's hardware, but it will also run on the future hardware. But it is also good for the European semiconductor industry because Europe's strength is in the open IP ecosystem for semiconductor, and world-leading European companies selling IP that mainly develop in Europe have open IP ecosystem. So this openness is very important. The open IP system rely on open standards to enable interoperability between parts. And competing non-European ecosystems are much more closer. They use proprietary programming model like CUDA. And we really believe that by using open standard, the open standard we promote in LIGATE, which are alternative to proprietary non-European solution, this is a great benefit for the European community.
So, Professor Cosenza, do you think that the LIGATE project represents a game changer in pharmacological, medical, and computing research fields?
Yes, absolutely. I think so. The project itself is based on a DOM-based software platform developed in the Exascale previous project, which is already capable of testing a large number of molecules per second. But in LIGATE, we go further. We are enhancing the platform by using advanced technology to support massively parallel hardware and heterogeneous hardware. And we also plan to scale on large-scale compute cluster on the supercomputer we will have the exascale supercomputer. In this sense, LIGATE represents a game changer for the pharma industry, as we will deliver an unprecedented computational power for drug discovery, but also for the high computing fields, high performance computing fields, as the same core technologies we develop in LIGATE will be useful for other applications.
Thank you so much, Professor Biagio Cosenza, for joining us today at this podcast, and thank you, our listeners. If you have any questions about today's show, you can get in touch on LIGATE Twitter, and feel free to subscribe Chelonia.Swiss website and be part of the community. In the meantime, stay tuned for our next interview.
Thank you very much for inviting me.